This puzzle is called Rope Skipping by Mad-Tyas. I got it from the Sudoku Testing Submissions channel on the CTC Community Discord. There's just two pretty simple rules. The first one that I'll look at is just the inequality sign. So it points to the lower digit, or if you think of it as a greater than sign, then it's the way I learned it in school was a like an alligator eating the larger digit. So this digit is going to be greater than this digit. So if I try to put an 8 there, that would be broken, although I guess that's not something F puzzles recognize. But yeah, this is the lower digit, the one um, that the arrow is pointing at, or the bigger digit is on the one that the alligator is eating. At least that's the way that I remember it. And the other one is equal lines. So the sum of the digits along, let's say this line, is equal to the digits that are along this line. And digits can repeat on a line just fine, as long as, of course, they can't repeat in a box or a row or something like that. But yeah, um, Mad-Tyas has done a number of these puzzles, and they're all great. So I really hope I can get through this one. I'll put a link to the puzzle in the description down below. Oh, I forgot to say, if you didn't notice, I added a notepad um, to OBS here, so I can type any notes. Like if I found out some set of cells, let's say red equals 17 or something. I don't know. If I find out something in here, I can write a note about it. Actually, I'll hide that right now. I don't need to have that up right away. But I'll have that in case something. Oh, and it doesn't say in the rules here, but it did say it in the rules in the submission that these lines. This is not a 6-cell line. This is 2 3-cell lines that cross each other. Green and dark pink are two different lines. The same thing happens here. This is a different line than this one. Whoops, this one. So that's just something to remember. Um, yeah, I think I said I'll put the puzzle in the description, and let's get going. So the first step is figuring out what this could total up to. And the first thing I immediately see is that the line adds up to something greater than 15. And that's because we have 3 lines here. And they totally fill this 3x3 box, but they also stick out a little bit. So, uh, if you're not aware, every box adds up to 45, and also every row and every column. That's because every row, column, and box have the digits 1 through 9 exactly once, and if you add up the digits 1 to 9, you get 45. So this box has 45. That means this is at least 48. Yellow is at least 48 because if we put 1 and 2 here, that's the absolute minimum we could put there. That would be 48. But we can actually do a little bit better than that because 48 divided by 3 would be 16. But if we realize that this box also is the same situation, where it's filling this box completely and then sticking out a little bit, we can't make this also be 16 because this would also need a 1, 2 to satisfy this being just sticking out with the minimums. So this is actually a minimum of 45 plus 45 plus 10, which would be 100, which isn't divisible by 3. 102 would be divisible by 3, which would be... 102 is divisible by 3. What is it? I can't... it's literally Saturday morning first thing. I just woke up like 20 minutes ago, so let's type that into a calculator because 102 divided by 3, because I can't think. That's 34. Wait. Oh no, divided by 6. No wonder that's way too high. Okay, well, that's not going to be correct either because I did... Hmm. Hmm, hmm, hmm. So we're at minimum 17 right now. So the thought I had was that this long line down here also adds to the same thing, of course. All the lines add to the same thing. But it's... the minimum along here is 1, 2, 3. The minimum along here is 1, 2, 3. And I was thinking the minimum along here would also be 1, 2, 3, which would be 6 plus 6 plus 6, which would be 18. So we have a minimum of 18 if we totally forget about, pink and yellow. But, of course, this middle box is kind of all connected here. Because as soon as we start introducing these other ones, it's going to be pushing all the values up together. So if we use all the digits besides 8 and 9, I'm not going to type in the other digits, that's easier to just type in 8 and 9 in the uncolored digits. That's 45 plus 45 for the two, for box 3 and box 7. That's 6 plus 6 for box 1 and box 9. And that's 45 minus 17 for box 5. What does that add up to? That adds up to 130, which isn't divisible by 3. So I feel like, am I just going about this the wrong? I feel like I guess we're not bounding it by a maximum. What would the maximum be? Yeah, I guess we need to take into account the maximum. So the minimum would be, we just added all this up and we came up to 130. Which if we divide that by 2, sorry, divide that, no, what do I have to divide that by? Divide that 130 divided by 7? So we have 1, 2, 3 for yellow, 3 for pink, and 1 for green. So 130 divided by 7 is 18.5. So minimum of 19. Maximum would be, if this was 39, I guess 38. This has a maximum value of 38. If we add up, or if we just leave out 1, 2, 3, the maximum is 39. Because 45 minus 6, but that doesn't divide by 2, so if we would have to do 1, 2, 4 to make 7, leave out 7, and we have 38. 38 divided by 2 is 19. Wait, what did I just say? 19 is the maximum and also the minimum. Oh. Oh, that actually works out. Okay. So these numbers are all slightly off. Or, no, these must be 1, 2, 4. Or 1, 2, 4. These numbers are slightly off. Of course, I keep doing that for some reason. I've done that in other videos too, where I delete the colors instead of deleting the thing. Let's add the notepad on here, and I can write that on here. So, lines equal 19. I think I made the text big enough. It's hard to tell because OBS just has like a little preview. But I think that should be good. Okay, so lines equal 19. So these add to, if this adds to 7, this adds to 12. And this adds to 12 as well. So there are 3 different 12 pairs, and I guess we'll be using 2 of them. We can't quite... Can we figure out what the 2 different... Are there just 2 different 19 combinations? Let me look at 19 in 3 cells. There are 5 different ways to do it in full. Oh, you know what? I literally have a notepad for this reason. These are the 3 ways to make 19. But we can't use a 2 because we just... we're using the 2 right there, of course, and we're using the 4 as well. So these are, sorry, I only have 2 monitors and I'm bouncing around between like 3 different windows. 379 or 568. And that'll be the same for up here. So this is, this is still 12. This is 7. This is 379 or 568. Okay. So lines equal 19. So this is 1, 2, 3, 4. There's 1 degree of freedom. Whoops, I don't know why I marked that. It's 1 degree of freedom along here. I'm like, oh, you know what? This can't be 1, 2, or 4. So this is a 3. So this is gonna be a 1, 2. That's really he's so. He, I don't know how he makes all the clues just so well put together. That this clue that makes everything just yeah. So this must be 1, 2, 4 because we yeah. If we tried to put a 4 down here, this would be way too large because we need 1 and 2 in every box. So this must be 1, 2, 4. Lines are 19. This is 6 plus 6 plus 7. Yeah. In the last puzzle of his that I did, um, I completed the puzzle, but it turned out once I showed him the video that I skipped a piece of logic early on. Like I just made a leap in logic, and it missed out on a few very nice steps. Um, so I decided not to post the video because I didn't want anyone to like watch it and think what I did was correct, and just like learn how to solve puzzles wrong. But yeah. So I really hope I get this one right because I really like their puzzles, and yeah. I also really like the equal line constraint. It's just so beautiful, and they use it so well as well. Anyway, so we have 19, 19. So that means these, we've used up the 4, so that means this can't be 4, 8. So this is, one of these is, whoops, one of these is 3, 9. We don't know which one is which. One of them is 3, 9, one of them is 5, 7. That leaves, what does that leave? That leaves an 8 and a 6. Yeah. I was going to type like yellow lines or something down here, but I don't think I need to do that. Just to remind this. Box 5. I don't need to. I'll just remember that these add to 12. I was going to make a note about that, but I don't think I need to. Okay, well, the next thing I saw was this. I don't know if it's necessarily the best place, but the minimum for this is 5, 6, because we have 1, 2, 3 in the box, and then a 4 in the column looking upwards. And I guess I could look at those, but I don't need to yet, I don't think so. Anyway, so this is a 5, 6 minimum, which would make this add up to well, 11, 19 minus 11 equals, why is my head hurting? I should probably not do these first thing in the morning, huh? 19 minus 11 is 8. So there would have to be, I guess this doesn't have to be 5, 6, but there does have to be a 1 on here. So this adds up to 8, maximum. Should I color? I don't think we need green colored anymore. I'm going to keep this, but so this green adds up to a maximum of 8 because the minimum we could put on this side, and I'm intentionally doing light and dark green there, so if you notice that, that's not a mistake. The dark green is a maximum of 8 because light green is a minimum of 11, which means this is always 11. Sorry, this always has a 1. But dark green is a minimum of 6, so this is a maximum of 13. Maximum of 13. How does that come into play? Has it already been 40 minutes? Or did I not start this at 0? No, it's only been 13 minutes, okay. Just looked over at the timer and I was like, holy crap. No, I guess I felt like I was cruising pretty well so far. Yeah, I don't see anything there. Although if this was 5, 6, I guess this could be 4, 7 and also be 11. I guess one thing no, that doesn't, that's not. I was gonna say we could analyze both of these lines together, and say that these have a minimum of 22, the 4, 7, 5, 6, and these have a minimum of 12, 1, 2, 3 on both sides. Actually, this can't be a 1, 2, or 3. Maybe this is where I need to look. This can't be, this is a minimum of 5, because it also sees the 1, 2, 3. And if I make this 5, 6, This is a minimum of 7. Sorry about that. My should probably not have texted one of my friends right before I started recording because, of course, they respond while I'm recording. So I've made this 5, 6. This would be 4, 7. And that's way too high. Because this is already... these are just minimums. If I make this 5, 6, this is just minimums along here. And we're already to 18. And, of course, we can't do 1 and 0 on the line. Or, yeah, halves or something. So we need to bump up the 5, 6 so that we can bump down this value. Right? Yeah. So let's, if we did 5, 7 here, then this could be 4, 6. Oh, it also lowers this value. If we increase this by 1, we can lower this one by 1 and lower this one by 1. So this will be a 6. So this is 16. Then this can be 1, 2. This could be 1, 2, 3, 4. I don't think I proved this. I think this is an option that works. Let's do works. Oh no, how do I want to write this? 5, 7, light green equals 5, 7 works. Okay. I'm gonna write that there just because I'm gonna delete these and see if I can prove that it can't be any higher. Whoops. Prove that it can't be any higher. So if we did like 5, 8 would be 13, which is what I said would be the maximum over here. Then this could be 6, 7, which would also need a 1, 2, 3. But this can't be a 1, 2, or 3. Oh, right. Wait, no, this could have a 4 on it. What am I talking about? This could have a 4 on it. So this could add up to 8. So this could be a... no? Wait, how did I make this one... Now, I should have taken like a screenshot or something. Now I need to retype this in. So this works. So why did this not work when I switched this to 5, 8? It does work. Okay. I think that was a brain fart in my head as I was doing the math in my head. I somehow didn't come up with this. Okay, so let's delete these for a second. Over here, I think the better way to look at this is what happens if I don't use 4, and let's do light blue for this area and dark blue for this. If I don't have a 4 in light... darn it. If I don't have a 4 in light blue, I just keep doing that, deleting the colors instead of the thing. If I don't have a 4 in here, then it's a minimum of 5, 6. Then this has to be a minimum of 5 still. Then this could be 1, 2, and that actually does work. Oh, darn. But I think it's going to push light green way too high, because it can't have the 4. Because the 4 down in yellow looking upwards. So this is a minimum of 7, 8. Yeah, that's way too high. Yeah, so if we don't put a 4 in light blue, it breaks. Okay. Oops. If we don't put a 4 in light blue, it breaks. What if we do 4, 5? That actually... that might work. So... light blue... actually... yeah, I'll do B. I'm used to writing blue, or abbreviating blue as U, because that's how it works in Magic the Gathering, but I think that would be confusing for most people. B I think of as black, but I won't be using black, so that doesn't really matter. No, has a 4. Okay, so if we do 4, 5 like this, then this adds up to 9, and this is still... well, what does this become? This becomes 6, 7, which forces 1, 2, 3. Because 13 is the maximum over here in light green. In light green, and in dark green, 1, 2, 3 is the minimum. 13, yeah, 13 plus 6, yeah. Okay. Just double checking my math after making silly mistakes. So this could be a 5. And then this could be a 1, 1, 3. No. Yeah, 1, 3. No, not at all. What am I doing? This adds to 9, plus 5 would be 14. This could be 1, 4, or 2, 3. Hmm. I was really hoping that would break it, and I don't see why that would be broken right away. They'll leave 8, 9 left over. Well, one thing I just noticed is, okay, so 4 must be on that, 9 can't be on a line. If we try to, actually 9 could be on, yeah, 9 can't be on a line. If we tried to put 9 even with the 4, this digit is going to be too high, because 4 plus 9 is 13, which is the maximum we talked about, because the minimum we can put on this triple here is 1, 2, 3. Actually, the minimum we can put on this triple is 1, 2, 5, which is 8. So this has to add up to, this is 4, 5, 6, or 7. That's not going to be a good thing to type in. But yeah, this digit is pushing that value too high if we try to put a 9 on the line. And the 9 can't be over here because it can't be paired with 4. So we know 9 is not on the line. I guess I haven't done this yet. The inequality signs just do a little bit of work. Actually gives us a 1-2 pair. Maybe that's what we were supposed to see. But actually that doesn't matter, I don't think. It doesn't prevent this from being 1, 2, 3, because this could just be the 3. Right? I'm just looking around and seeing if I broke anything by doing this. Hmm. So let's actually look at the options here. This, I said 4, 5 work. Which one was it? 4, 8 doesn't work. I said this could work, but it can't. This would be 12, and then this would need to add up to 7. But this can't be 1, 2, 4 because of this. So that's 4, 5, 6, 7, which is a little bit better. And 4, 7 would be 11, and then we could have 5, 1, 2 here, which would be 8. 11 plus 8 is 19. Okay, that's a little bit more options than I thought. Well, if we, no, we said that if this is 4, 5, 6, 7 works over here. Because we could go 6, 7, 1, 2, 3, that works. And, well, I guess I don't need this line anymore because so much stuff is working that, actually I'm gonna write that so I realize what that means. So much stuff is working, and I don't think I need this anymore. That, yeah, so much stuff is working. So maybe I need to look somewhere else? I guess, so this always has a 1 on it. I said that earlier, but I removed that. So then this one can't be a 1. So one of these two is a 1. Must it have a 2? 1, 3, 4 would be 8, which could go with the 5, 6 over here, which would go with the 4, 7. Wait, okay, now I'm getting a little. Yeah, if this was 8, this could be 5, 6. This could be 4, 7, and this could also be 8, and it could be 5, 1, 2. No, this couldn't be 5, 1, 2. Wait, does 4, 7 actually work? This is why I have notes, why I'm supposed to be taking notes about the combinations, and I'm just not for whatever reason. So this is 5, 6. This could be 4, 7. Then this has a minimum of 7, which is already 18. Yeah, 4, 7 doesn't work. Okay. Yeah, because this would be 4, 7 is 11, plus 7 is 18. So that doesn't work. Wait, could this be 4, 7? Wait. 4, 7, 5, 8. And then this could be 6, 1, 2. That's still too high. 4, 7. This would be 17. Yeah, this would be 20. Okay, so I've convinced myself that 4, 7 doesn't work. Okay. But this always has a 1 on it. And if it's... So, how could this be 5, 6? If this was... So we go back to the original thing I was thinking. 1, 3, 4. That would require this add... This... I cannot speak either. Dark green sums to 8 in this case. If we don't use a 2, 8 is the minimum. Which means light green has to sum to 11. But we can't use 5, 6 anymore because that would break light blue. So this line must have a 2 as... Whoops. Must have a 2 as well. And this can't be a 2. Whoops. Oh, that's a 1-2 pair then. Okay, that's definitely progress. So this could be a 3, 4, or 5. No, if we made this a 5, that would run into the that would run into the 11 problem again, because we thought this could add up to 11, and it can independently of blue. If we only look at green, this works because it adds up to 8 and 11. But then this line over here doesn't work because it would be a minimum of 4 and 7, and then the 7 goes there, and what we've looked at like 50 times now. But I keep having to convince myself because I don't want to make a mistake, and I feel like I'm probably going to. Which gives us a 4, actually, and actually gives us a lot of digits. Holy crap. Maybe this must be where we need to look. Okay. 4, 2, 1, 2, 1, 2, 1. Holy crap, I did not expect... Those digits just kind of came out of nowhere. I was just kind of working to give us, anything, and that was... that. Okay, so I think this line also has to have... Oh, no. Yeah, it does have to have a 1 on it, yes. Okay, so I made a series of errors in my addition along here. Hopefully I trimmed all of that out. And we can start fresh from something that works. So, I just want to show first that 7 does not work in light blue. That was kind of one of the things I was worried about, that I kept thinking maybe it does, maybe it doesn't, and then I proved it wrong, then I tricked myself into proving it could work, and let's just prove it doesn't work. So if I did 4, 7, this would have to add up to 8. This would have to be a maximum of 5, and that's also the minimum it can be because it sees 1, 2, 3, 4 in the column. So that'd be 1, 2 left over. This seems to work. However, this light green must be at a minimum 6, 8 now, which is too high. This is a maximum of 13 because this has a minimum of 6. 14 plus 6 is 20, which would break the line. So if we roll this back, this can't have a 7 on it. That is, I've convinced myself that that's true. We should be good there. So now this has a minimum. This can't be 5, 6. So this has a minimum of 5, 7. 6, 7 also works. 5, 8 also works, theoretically, because it has a maximum of 13. But the minimum is 5, 7, which makes this 1, 2, 4. Let's just look at that. Because this is 12, this would have to add to 7. So this would be 1, 2, 4. If we made this add to 13 instead of 12, this would be 1, 2, 3. So we only have 2 options for dark green, and that's 6 or 7. And we have this 1, 2 pair here, which takes out 1, 2 there. If I cut out, I might have cut out when I looked at the equality sign. The reason why this couldn't be a 4 is just the equality sign. I'm not sure if I cut that out because I kind of looked at that in the middle somewhere. Yeah, so this is 3 or 4, and then that makes this a 1-2 pair, which then gives us a 4 here, based on this pair, which becomes 2, 1, which then gives us those digits, which also gives us these digits. So this adds to 12 or 13, and this adds to 6 or 7. I think we're good there. Now, on this side, this adds to 9 or 10, so this adds to 9 or 10 as well, but obviously kind of flipped. What are the options for this cell? Could this be a 7? If we did 7 here, this would be 1, 2. This would have to be 4, 5, which would then make this 6, 8 again. So this also can't be a 7. Whoops, this also can't be a 7. So this is just 5 or 6 because it can't be any lower because of the 1, 2, 3, 4. So this is 7, 8, or 9. It'll be a 9 plus whatever high digit we don't use, and light, or sorry, and over here it's the same way. Whatever's not used in light green goes with the 9 off the line. Now, if we minimize all of this, these two cells add to 5, so this would be 1, 2, 3, or 4. I don't know why I did that. Yeah, 4, 5 is 9 plus 5 is 14. This would be, have to add to 5. This can't be a 1, this can't be a 2. Now, because we removed the 1 from over here, this can't be a 4 ever. The only case where this could be a 4 is if this was a 1 and this was a 5. Okay. Oh, this 1, 2 also looks down. So that removes a couple options. Not a huge amount, but a little bit. And one important thing is that 1 doesn't have to be on this line. 3 can go with 2. And 5. I think so, at least. Whoops. So, yeah, we don't get an immediate value. Okay, I'm trying to get my head back going correctly. I think, so this has a 5 or a 6, this has a 5 or a 6. That means this 5 or 6, and I'm going to change this to light blue just to make it a little bit easier to read. But this 5, 6 is the same as whatever 5, 6 that is used in here. Because if we tried to make them different, well, I guess the way, whatever 5, 6 we use in here is not used in light green. We use the other one in light green, which means this light blue uses whatever one was the initial one, which was this one. Yeah. So this is either 4, 5, 5, which would be 4, 5, 5, which would be 14. It's either 4, 5, 5 or 4, 6, 6, which would be 16. Yeah, those are the options. So what does that mean? I guess this middle digit here can't be an 8, though that doesn't, really matter all that much. I was just thinking, if this was a 5, that forces this to be the 3, 9, and forces this to be the 5, 7, but I don't think that actually matters at all. Ooh. Okay, here's an idea. We have, well, I guess technically it's a Y-wing, although it doesn't help in that sense at all. These 3 digits, that's a really ugly color, I can't do that. This 3, 4, if we can force this to be a 4, and this to be a 1, then this, breaks, this cell. So if we put a 4 here, This is a 4, obviously. This is a 1, so this would be a 3. So this would be a 2, this would be a 5, this would be a 5. This would be 6, 7. And that would be too much. Let's go through, wait, let's go through it again. This is a 4, this is a 1. Whoops, just this cell is a 1. This is a 3. The only way 3 here can work is if we go 2, 5, which then forces the 5 up there, and takes the 5 off up there, which... Oh no, it could be 6, 7. Yeah, but 6, 7 adds to 13. 13 plus 7 is 20, not 19. So 4 doesn't work in dark green. So this must be 3. Which means this always adds to 13. This can't be a 3, this can't be a 9, this can't be a 3, this can't be a 9. I guess a 3 is up. One of these is a 3 up there, and we do have... One of these is 3, 7, 9. I don't think we're at the point where putting 3, 7, 9 in one of these would hurt anything. Huh. Okay. Kind of expected that to yield more results than just giving us this 3. This adds to 13, but this still can add to whatever we want. If this is a 1, that makes this a 1, but I don't think that matters. I was trying to look at, like, could we break the puzzle by, like, forcing these to somehow break with over here? I don't see how to do that, though. Because if, like, I was thinking, like, if this is a 2, then this is a 2. But that doesn't do anything, I don't think. This is also as a minimum of 5, but this could be a 4 over here. This line can't have a 2 and a 3 now. Maybe I need to look down here. This has a minimum of, I guess it has a minimum of 7, which isn't that large. Because we could put a 1 and a 4 on here, and then a 2 right here. Actually, no, we can't do 1 and 4 because of this cell. This is a 1 or 4. So this is a minimum of 1, 5, 2. I think this is the absolute minimum this could be. So that's 8. So this adds to at least 11. But that's not that rich. Like, this could be 5, 6, or 7. And this could be 4, 5, or 4, 6. And yeah, I do think we're going to need to look at this line. I think that is... The fact that these lines look right at each other, I think, is going to be important. So what if this was a 1? Maybe that's what we need to look at. If this middle cell was a 1, this would be a minimum of 4, 5, and this would have a 1 over here. Which 4 is now ruled out of these two cells. This is 10, which would necessitate 4, 5. But this breaks the puzzle. Okay, so one second. Let's back up and I can explain this clearly. So if this middle cell is a 1, minimum for this is 4, 5. Because we have 1, 2, 3 in the column. So we have 4, 5 here. Minimum for this, of course, is 1. So now we have 10 so far. We need this to add up to 9. We've already used 1, 2, 3. This must be 4, 5. But now where do we put 4 in this triple. 4-5 is this 4-5 rules it out of here, and actually that's enough. These both have to be 2. At this point. Okay, so this middle digit is a 4, which makes this a 2, makes this a 1. And that literally doesn't see anything over here. What is going on? I guess one of these is a 1 now. We have this one up here, and now, whoops, and this one over here looking. Okay. So this is a minimum of 1-5. If this is not a 2, if this cell is not a 2, it must be a 4. This is a minimum of, if we don't even need to look at this yet. But if this cell is not a 2, it sees a 1 and a 3, so this would be a minimum of 4. And then these two minimums are 1-5. Adds up to 10. This would have to be 5-4 like this. Which makes this like this. And that actually works. Oh, darn it. I was thinking we could force a 2 there, but I don't think that quite works. There are just so many low digits that are going to be forced into, like, these cells. But, okay, so the absolute minimum is 1-5. This must have a 1 on it. Yeah, if we don't put a 1 on it, then it's going to be a huge number. So this must have a 1 on it down here. So if we do 5-2, 1-5-2, that's 8. So this has to add up to a maximum of 11. So this adds up to a maximum of 11. So this is a minimum of 5. This is a maximum of 6. But we could lower this to 5 or 4. And so we could raise this to 6 or 7. Is that right? This is a minimum of 5, so this could be, yeah, I think this is right. If this is a maximum of 11. I really don't like that color. Every once in a while I try to use it thinking it'll be, it'll be good. Okay, so light yellow is less than or equal to 11. Okay, so if this adds, there are a lot of options if, am I doing this math right? 1-5-2 is 8, makes this add to a maximum of 11, yeah. If I make this 5 and 5-4, this adds up to 10, and that could be the 4 here, or all the way up to 7 on here. This could be 2-1-7, I think. Whoops, 1-7. Oh, we do have an X-wing on 1s. Oh, that's going to give us a little bit. Or sort of an X-wing on 1s. So where could a 1 go in this row? Can't go in here because of the 1-2 pair. Can't go in here because of the 1 pencil mark. And can't go here or here because this is a 1-2-4 triple. So this must be the 1. And of course 2 or 4 is greater than that. Did I use the fact that this couldn't be a 1 ever? That might have just been for symmetry, but I don't know. I don't think that equality sign is necessarily needed. Oh, we actually placed the 2 in box 8. Where it's the same thing as with the 1s. Whoops. So we have 2s right here. So where can 2 go in column, in row 7? Can't go along here because of the 2-4 pair. Can't go along here because of the 1-2 pair. Can't go here or here because of the 2s up there, so this must be a 2. Okay, it's always good to get a digit, although if we force that to be a 4, that would be really helpful. Yeah. Okay, so this is 1 5, 1 6, 1 7. One of those. Which means 8 is in one of these other cells. I don't know how to pencil mark that in any useful way. I guess this cell is also minimized, or sorry, the minimum of this cell is also raised up. So this cell is a minimum of 5 as well. Yeah. These cells together have a minimum of 45 minus 6 is, or minus 6 minus, if we, why am I? Minus 6, 6 plus 20, yeah, it'd be 23. 6 plus 17. If we put 8 and 9 out here, these 4 digits add up to 22, so average of 11. So, well, this is at most 11, so this is, yeah, anyway, so if we just imagine that this is around 11, that means this needs to be around 8. Oh my gosh, okay, so that's pretty restricted as well. That's pretty restricted as well. So how can we do this? So minimums up here are like this. 5, 2, 1, the 2 tells us which direction those. So this is this is the absolute minimum. So the maximum over here is also 11. Let me think about that again. This cell has an absolute minimum of 5 because it sees 1, 2, 3, 4 in the column. It sees a 2 here, sorry, a 5 and then a 1, 2 would be the minimum. 5 because it sees 1, 2, 3, 4. And then 1, 2 is the absolute minimum you could throw in there. So that adds up to 8, which means these need to add to a maximum of 11. But we just said that the minimum that these 4 could add up to, 4, 5, 6, 7, is 22, which would put 11 in both of them. And we said this also needs to be a minimum of, or a maximum of 11. So if this is a maximum of 11 and this is a maximum of 11, like we can't lower that anymore. If we start lowering that, we're gonna have to start using like doubling up on a digit, because that adds up to 22 at a minimum. So this does add up to this does add up to 11, which means this is 5, 2, 1, which means this can't be 5, this can't be 6. So this is 5, 6, or 4, 7. Again, somehow that, oh no, that forces a 1 there, which does a little bit, but not that much. It gives us a 1, 2 here, this must be a 1. Gives us a 2, 4, means this is a 5, this is a 6. This is the 4, 7 pair. This is 7, 8, 9. This can't be an 8. What's left in the row is a 3, 5. Which means this can't be 5, 3. That was one option I had, right? If this... No, it's not an option that I had. No, it's not an option I had. It was 5, 4 was the option. If we have a 5 here, this will be a 4. Can this be a 3 any longer, actually? If this is a 5, this needs to be a 4 to add up to 10 because the 5 repeats up here. If this is a 6, this is a 2 because this is 4, 6 up here. We need 9. So this can't be a 3. Oh, even more helpful, and would have given us that not 3-ness a lot easier. This 5 makes this a 3, 9. Means this is not a 7. This is not a 9. This is a 9. This is a 7. No, we don't know that this is a 9. The pencil mark was on this side, and my thought was that that was going to be the... Oh, but this is a 5, 7, which forces 6. Okay. So this must be 2. Now we're cruising. And I say that, and I don't see what to do next. Let's get rid of that color for a second. Oh, there's a 5. There's a 5 there. This can't be a 5. Why did I do that? This can't be 5, 8. So this is a 7. So what's left in this? Oh, so these can't be 7. What's left in this box is 1, 2, 3, 4, 8. And we've broken the puzzle. Oh, yeah, I see what we did. Okay, it was literally the last thing I did. This is 6, 7. This is an 8, not a 7. I don't know what I said, but that's just the way I did. I just noticed that there was nowhere, like, if 8's matched up here, which would force an 8 over here, but of course that's a 1, 2, 4 triple, so that couldn't be it. So this is a 3, 4, 7. Apologies if you can hear my chair. This 7 puts the 7 down there. This 4 puts this right this. So we have a 3 and a 3 down up here. So one of these is a 3. I guess I can get rid of all of that now. We don't need light blue colored. We don't need green colored. Okay. So this 3, this could be 7, 9 like this. Or this could be 3, 7, 9 like this. What about 5, 6, 8? Oh, I have broken the puzzle. What did I do? Oh, shoot. It's broken at this point. Oh, I know what I did. I'm dumb. This must have a 6 on it. I pressed 6 to... I need to just slow down and think about things, I guess. So this is not 8. Again. Oh my gosh, I'm annoying myself with how much I'm messing up. Okay. So this is like this. This is a 2. This 5 sees this. This is a 3. This is a 5. This is 3, 4, 8 for the 3rd time. Okay. Okay, what's left over here? Oh, there's a 3 here. This is 4, 8, 6, and there's a guaranteed 6. This is 4, 8, 9. Oh yeah, there's a guaranteed 3 over here. Okay. Oh, what do I have here? So this is 11. So this is minimum of... This must be the 5, yeah. So that puts a 5 here, which gives us this is 6, 8. And this 6 resolves that. 8, 6. 6, 4, 4, 3, 8. This can't be a 4, these can't be 8s. What's the other one? 3, 7, 9. This can't be a 3. This can't be a 3 because of the 3 over here. Whoops. There's, to finish off this row, it's 7, 8, 9. And the 7 must be in box 8. What about over here? We have all the 3s to put a 3 there because of this 3 ruling that out. So this is 3, 7, 9. Not quite known as far as I see. So this line is 5, 6, 8. This can't be a 5 or a 6. There's a right there. So this is an 8. So this is a 4, 6. This is a 4, 7. This is a 7, 9. This is a 9, 7. This is a 7, 9. This is an 8, 9. This is an 8, 9. Okay, so this is 6, 9. Yeah, and there's a 9 right here, so this is 9, 6. This is 4, 3, and there's a 3 right here, so this is 4, 3. Oh, there's a 5 right here, which makes this 5, 7. Well, let's just get rid of these colors. I don't think they're helping me right now. Does anyone else, when you delete a massive amount of colors, it just like makes the whole puzzle look funny? I guess this has to be an 8 for the column. So this is a 5 or a 6, and there's a 5 right next to it. So this is an 8, this is a 6, this is a 7, this is an 8. This is an 8, this is a 5 because of this 8 right here. 4 is right here, 5 is right there, 7 is right here, and 9 goes there. Whew, that was a toughie, especially since I made a bunch of mistakes. Hopefully, overall, I fixed everything. Definitely a tough one, but I really enjoyed that. I do need to slow down with my solving, I guess. When I feel like I get a string of things resolved, I just need to slow down and make sure I type everything correctly, because that caused me problems there at the end. Uh, just like small annoying problems that didn't need to happen. It wasn't like a mistake in logic, it was just a mistake in like like here I was like, oh, this is a 6, therefore this has a 6. So I typed the number 6, which removes 6 as an option. So then I was like, okay, this is 4, 5. Let's just double check that I added up all these lines correctly. So 6 plus 6 plus 7 is 6 plus 6 plus 7 is 19. 10 plus 6 is 7. Sorry, 10 plus 6 is 16, plus 1 plus 2 is 19. 13 plus 6 is 19. 12 plus 7 is 19. 12 plus 7 is 19. 8 plus 11 is, 8 plus 11 is 19. 11 plus 8 is 19. 5, 8, 6 is 19. 7, 9, 3 is 19. Did I say 18 a couple times down here? My brain is just fried. I really shouldn't have done this first thing in the morning, I guess. 7, 9, 3 is 19. 6, 8, 5 is 19. Okay. I think I did it. I got the correct solution. I think I hit most of the logic along the way. I do need to trim out a bit in the middle there where I made some mistakes, but I'm very happy with this puzzle because completed. I got the correct answer. I think I did it logically, even with mistakes, though. That's okay. Everyone makes mistakes. Thank you, Mad-Tyas, for the puzzle. It was great. I really enjoyed solving that, figuring out all the little bits of logic. And thank you guys for watching.